A force F is applied on the system of blocks, and the system of block is moving with the constant velocity. That is very important condition that is given in this question. So let's first explore this condition. So when we say it is moving with a constant velocity, it means that the whole system is moving with a constant velocity. Not only that, so I'm writing A of the system is 0. All right, it means that the sum of all forces equals to 0. And when we say sum of all forces is equal to 0, it means that this force F is, especially this force F, is countered by the other forces which are in this direction, and that is of course the forces due to the friction. So mu m1g is a frictional force applied by the surface on the block m1. This is a frictional force applied by the surface on the block m2, and in the same way it is mu m3g. So this force towards left is countered by these three forces to the right. That's why, and that's why it is moving with a constant velocity. And second point is, when we say it's a moving with a constant velocity, dear students, remember that not only the whole system is moving with a constant velocity, it means every component of a system is also moving with a constant velocity. It means that A3 is also 0. So which means that the forces on the block 3 are also balanced. Now here in this question, we have to find out what is the force applied by the block 1 on block 2. Okay, so to know this force, let's go first of all about the free body diagram of this block. So students, this is a block M3. All right, how many forces are exerted? I had already told you that the total acceleration of this block is 0, which means that the forces along y-axis are balanced. That is, let's say n3. Normal force is equals to m3g. All right, and the forces on the x-axis are also balanced. So this force is mu m3g is actually the frictional force applied by the surface on the block m3. And students, this is the equal amount of a force, a contact force, which is applied by the block 2 on block 3, which I can say why not F23, the applied by 2 on 3. So from this, can I say that the mu m3g minus f23 is equal to 0 and mu m3g is equals to f23? Why it is important to draw its free body diagram and then making an equation? Because we will use this value of f23 in the next free body diagram of m2, right? And don't forget what we want to find out, the force applied by 1 on 2. So what will be its free body diagram? So students, A2 is 0, its acceleration should be 0, which means that once again the forces, this is a normal force on the block 2, n2, this is a weight that is equals to m2g. These two forces are equal. Now important forces are the forces along x-axis. Now this is a force applied by, because m3 is also pushing m2 in this direction, this is a contact force. Okay, so this is a force applied by 3 on 2, so 3 2, let's say. Whereas the force that 1 is applying on 2 is in this direction, in opposite direction. So we can say this is a force applied by 1 on 2, so F12. And this is a force that is actually required in this question. And don't you think that these two forces are equal? And don't forget to add this force also in this direction. Which force? Which I had already drawn here is the force applied by, frictional force applied by the surface on the block 2. Okay, so what is the equation that we got from this? So we can say that the sum of these two forces, mu m2g, is equals to F12, okay, which is required in this question. And don't you think that the force applied by 3 on 2 is equals to the force applied by 2 on 3? Just the difference is that the both have opposite directions. right? Otherwise, their magnitude is same. And what is the magnitude? Dear students, this is a magnitude mu m3g. So let's write here mu m3g plus mu m2g is equals to the force applied by 1 on 2. So finally, you can take mu g common, and inside this is m2 plus m3. So the right answer should be option A without any doubt.